Let's use the Examples panel to ask the assistant about the dataset. This response consists of two parts. First, the assistant explains the process for obtaining the result and lists the function calls that will be used. The second part is a predefined template response, which is dynamically populated by executing the corresponding function in the backend. Notice that in this case, the template response ends with a question. Since the assistant is aware of the conversation context, a simple yes from the user is enough for it to understand that more in-depth statistics are being requested. Let's say we want to study some outliers. We can ask the assistant how many data samples have an outdoor temperature warmer than 28 degrees. Notice that we are using the word warmer, and the assistant correctly interprets this common knowledge and translates it into a function call with the appropriate parameter to filter the data by the minimum value of the outdoor temperature feature. This predefined template answer provides a general description of the genetic programming model that is ready to use, and even includes the exact program dynamically extracted from the model file. Let's say we want to dive deeper into a particular data sample. Users can make complex queries that may involve multiple function calls. In this case, the results of these calls will be combined into a single message, but the output remains structured and populated from predefined templates. The Explainability Assistant helps users understand how different features contribute to the final prediction by using a SHAP explainer. Feature importances are computed dynamically in the backend. Additionally, the assistant can provide more detailed information about the methods it uses, offering transparency into the underlying processes. Another way to explore the effects of different data features on the prediction is by asking what-if questions. In this case, the LLM infers the context for a function call, and the backend substitutes the specified value, handles the necessary calculations, and returns the result within a dynamic template. We can take our exploration even further by leveraging counterfactual explanations, generated dynamically in the backend using the DICE module. Counterfactuals allow us to explore hypothetical scenarios, showing how different values would lead to different model predictions, and helping to deepen our understanding of the model's behavior. Finally, we can ask the assistant to use the model to predict a new data sample by providing updated feature values. This concludes our brief overview of the application in the energy consumption use case.